Work it, make it, do it, make sense.
All right, good afternoon. So we have quite a lot of material to cover, but hopefully you'll take away quite a lot of different lessons about how you architecture systems for change. The topic I'll be talking about today is really about evolutionary architecture. And I want to kind of give you some background as to why this is kind of important. I've been working with sort of agile methods for quite a while, and in all other sort of environments, we talk about adapting to change or responding to change. And systems development, as they evolve over time, are starting to sort of get shorter and shorter lifespans, and you still have to deal with a lot of legacy systems. So when you're actually building new systems, what do you actually do and you sort of think about when you're actually thinking about architecting for change? And that's kind of the heart of what we'll be talking about. And I've kind of had a lot of experience working with ThoughtWorks. So ThoughtWorks is a consultancy. We work with lots of different companies, help them build new systems. So we're kind of responsible for things like continuous delivery in the lean enterprise. And if you follow Martin Fowler, he's our sort of chief scientist that talks about a lot of these principles. And a lot of the ideas behind evolutionary architecture aren't really new. It's just sort of seen through a different lens of looking at architecting specifically for change. One of the things we produce is just probably interest to all of you technical people is our sort of tech radar. And it's a kind of collective view of what we're seeing with clients around the world. So it's kind of the practices, the tools, techniques that people are actually using, sort of charted out in sort of a different set of rings and advice about what things we're actually seeing as being painful, so holding, or things that people are actually trialing that you might actually want to think about in your own sort of companies. So there's different categories around that you might actually benefit from. We published that one quite recently in the last month or so. My background is actually around sort of technical architecture. So I normally work with systems and I work with clients, and we actually help them build and evolve systems that they currently have. And I've worked with sort of tens of different clients around the world in lots of different industries. Everything from your sort of big banking kind of organizations, telecoms, all the way down to sort of small startups. And it's quite interesting when you actually think about the ecosystem of how people make and design systems, and maybe the ones that are a bit more successful. And that's a lot of the lessons that we've actually sort of taken with understanding what actually makes a system changeable over time. And I'm actually working with our CTO, who's Rebecca Parsons, and she's on the left-hand side, and Neil Ford, who you might recognize from different conferences as well. We're actually working a book on this, and we're hoping to have probably a first draft published with O'Reilly. So if you have like early access on Safari, hopefully there'll be something around summer this year. But we should actually have a book that talks about these concepts in great detail, as it's something that we've been sort of talking about for the last kind of 3 years internally, and we were wanting to actually start sharing a lot more of these ideas broadly. Now, the reason that we actually think about evolutionary architecture versus, say, something like Agile is really this idea around thinking about, well, what are the consequences if we look at our ecosystem as evolution? What does evolution actually mean, and what do we have to learn from sort of biology in this evolutionary sense in our software world? Well, one of the first things that evolution teaches us is really about this idea of change, and that actually change is pretty much inevitable. So in a biology sense, you have ecosystems that co-evolve. So something will actually change in that system, and the inhabitants and the sort of species in that system actually have to evolve in order to compete and evolve and adapt to that sort of environment. And in our sort of software world, there's actually kind of two major types of change that I'd like you to think about, and whether or not we're actually designing for both of those types of aspects. And you can kind of broadly classify these in both a technical sense as well as a domain sense. Now, I know most of us have some sort of Java background, development, architecture type background, and we're probably more suited to actually really understanding the technical side to the area and what changes actually emerge. But actually, we're also victims to the environment of what ecosystem from a business sense and how that actually affects the technologies that we actually have. So if we actually think about that this change is inevitable, then what does it actually mean when we're actually thinking about the systems that we evolve? Can we actually predict what architecture we actually will need in the future, and will they actually be the right choices? And if we actually know that actually change is going to be coming, actually, we're going to be optimizing for the fact that we don't know what's actually coming. And so rather than actually trying to architect for too many things up front, we're actually starting to think about, what are the possible changes in our ecosystem that we actually care about, that we might need to think about, and what are the possibilities around that? So what are the things that we actually care about? And I guess this is kind of a bit of a challenge, right? In that I think as the industry has kind of adopted Agile, there's kind of this whole thing around big design up front, you don't need this, Yagni. And we've kind of maybe flipped the other extreme of maybe not enough thinking up front about what are those possible changes, and there's a balance in between. And what we're sort of trying to nudge is that there's this idea that's kind of in the middle that isn't really about crystal ball glazing and saying, these are all the changes that you're actually going to have, and therefore we're going to architect for that, and we're going to sort of spend a program, a sort of a 3-year architecture and develop this. But actually we need to optimize to understand what are the things that we actually do want to anticipate and actually make changes for. And that's really the essence that we kind of posed ourselves when we were actually talking about this idea of evolutionary architecture, which is, what if we specifically architected a system for change? What would that look like? How would that drive our decisions and our behaviors of how we actually implement the architecture, and also how we actually try to understand how we support change overall? So, as I said, we're working on this book, and we have a definition for evolutionary architecture. And it's kind of key that an evolutionary architecture supports guided, incremental change as a first principle among multiple dimensions. Now, it's really quite important to actually think about what this actually means. So guided means that we're not simply adapting to the environment. So it's not that we react to what's actually happening. If we're actually guiding our architecture, we're making explicit choices about what we do and do not use in response to the environment that we're actually having. And we're also trying to anticipate the types of changes that might actually happen. And it's really important that we actually have this idea of incremental change. So I think, particularly when I work with maybe larger organizations, telecoms or banking, there's this idea of, we need to anticipate all this change up front, and actually we're going to fix in all the change that we want and make that really hard. And if you've ever worked in a system like that as a developer, you've probably experienced all these levels of indirection which make your job really hard and actually makes daily change and making changes to the system harder as well. So there's a balance in between. And this is where the idea of actually this incremental ability is a really key thing, is that it's not just a once-off aspect of you have an architecture for change. It's actually you're also trying to increment change through your system and test whether or not your architecture supports the change that you care about. And it's really kind of key to actually think about this idea about principle of change as a first principle among multiple dimensions, because a lot of the architectures we see are kind of more optimized for one dimension or the other, and not for both, and we'll kind of talk about that. And this is really actually starting to think about, well, does your architecture support change already? So we'll have a look at different types of architectures and understand what the implications are for that. So maybe some common architectural patterns that we're all kind of familiar with is maybe your big ball of mud. So how many people have maybe done a dependency map and seen something like this before, where all the lines are kind of crisscrossed? Hopefully you don't have to deal with that, and maybe your systems are a lot better, but we're all kind of used to this as probably an industry, right? You have perhaps your classical tiered layered architecture, where you have different layers representing different types of tiers. Perhaps you have your sort of microkernel type of architecture, and then maybe a bit more of the microservices aspect. So we'll have a look at each of these architectures in detail and actually try to understand how they actually support change. And more than that, what sorts of changes they actually support as well. So we'll have a look at each of these and understand maybe what are those changes and how they actually support stuff. So this diagram actually comes out of an architectural analysis that we did with a client of ours, where the circle represents the number of classes in the system, and each line represents a call out to another class in that sort of system. And so this interweb of calls actually demonstrates how much coupling there is between individual classes in a sort of system. And if we actually had a bit more of a modular system, you'd probably actually see sort of strong aggregations of arcs within one area, but certainly not crisscrossing like you do as part of a map, or in this diagram. And so in this kind of architecture visualization, I would probably argue that this kind of architecture doesn't really support any change. So if you need to swap out some type of technical layer, so you need to swap out your persistence layer, there's probably a whole bunch of classes you're going to have to change, then you have no idea where you're going to start. And as you start to sort of pull out one dependency, you start to actually realize this thing is touching all these other things, and that change becomes really hard as well. Now, if you try to add in some business features, so let's say we want to change how we price something, or maybe we want to add a new product, once again, maybe it's not really clear about where we go in the system to actually do that. And we actually have to do an impact analysis on the entire code base to understand, well, how does that product actually affect everything? And how does the pricing actually affect other parts of the code base as well? So from this kind of perspective, the big ball of mud's not very good at actually supporting both our technical and the domain kind of perspectives. And so obviously, if you've had to deal with this, you've probably struggled to actually make changes to this effectively. And it's not that you can't, it's just it's probably going to be quite a hard slog to actually get there. Now, we probably move on, and probably because of adoption of sort of web and frameworks like Spring, we probably end up with something like a sort of tiered architecture in general, right? So we have a nice sort of abstraction over the database. We have our sort of entity objects that map these things away. We're using entity sort of framework attributes. We can perhaps swap out the implementation of that database if we like. Maybe if we're lucky, we've done it good enough that we can actually swap out for a document database rather than a relational one. And then we have our nice kind of service business layers, and that's kind of nicely decoupled. And then maybe we have our sort of presentation tier of actually how we actually render the screens that we actually care about and get information in and out of our sort of system. Now, this kind of sort of tiering makes sense from a technical perspective in that, we actually probably want to change out, where maybe let's change out the database. Where would we go for that? Well, in this kind of tiered architecture, it's kind of clear from our implementation that we actually change out the persistence layer, right? And so if we actually want to change something about how we've implemented our sort of service layer, we probably go to that sort of logic layer, and that's okay. But if we're actually starting to actually think about perhaps a domain layer, so we actually want to change the way that we register customers, and that changes our sort of data model quite fundamentally, we still actually probably have to touch quite a lot of the code base, and we have to understand which parts of the layers we actually need to touch. And often this will mean that we actually have to touch every single layer in different sections, and so it's not in a very cohesive sort of unit. So our argument with our classical tiered layered structure, if we're not doing very strong modularization, is actually this architecture, when not done very well, is actually one layer of change. So we can support our technical changes, but not necessarily the domain changes of how the business would like changes supported. We still have to understand the impact on every single part of the system because there's no clear separation of concerns vertically rather than horizontally. Now, another consequence of this kind of tiered layered architecture depends on how you've also implemented it. So, we like consistency because consistency makes change easier. It's predictable, right? And what's kind of interesting is that actually if we want to add a new sort of attribute, so say we want to persist, say, a Twitter handle for somebody on the customer rather than just an email address, we actually have to go through every single layer if we want to be consistent. So we have to have another attribute on the screen. We need something in our presentation layer. We need something in our sort of business layer, but all it's really doing is calling our persistence layer because there's nothing interesting in that. And then we have to actually persist it and have the field in the database. So we've actually also added a whole level of accidental complexity of things we don't have to do just because the business wanted something to change, and we wanted to be quite rigid with our sort of architecture. So some really good examples of, I guess, tools that actually implement this are probably Spring that we're all familiar with, Rails, and there's a whole bunch of other sort of frameworks that use that. And so it's not necessarily a bad thing, it's just being aware that these are the types of changes that you might actually support and not support as a result. Who's familiar with maybe the microkernel architecture here? Okay, a few hands. So a microkernel is kind of this idea of a core system that supports certain types of changes. So if you've dealt with a rules engine, Maven is a good example. Different types of things which define a certain set of behavior, but they allow extension points for change. That is effectively your microkernel type of architecture. So the core of your architecture is based on whatever the implementation of that microkernel is, and then you've defined extension points that allow people to plug in extra types of behaviors that you want. Now, this sort of change can actually support some types of change, in that if you actually want to swap out certain parts, you can, but you will always be constrained with whatever it is that the microkernel will allow you to do. Now, a really good example is if you've tried to build something that's much more complex than an Apache project with your core lifecycle within Maven, you probably realize you start to sort of work around the core system of the standard build lifecycle. So you start adding plugins that kind of step over another part of the Maven phase that does something a little bit different because the core system you can't change, but you want it to do something fundamentally different. And this is one of the challenges when you actually work with this microkernel system, is that if your domain fits that core system really well, then you win. You don't have to worry about that. But if that core system is actually something you want to change, you effectively won't be able to. You'll be able to change things at the boundary, but you won't really be able to make changes to the core system and be able to support changes like that. So from one perspective, you can actually make some changes, but you are always constrained by whatever it is that the microkernel actually allows you to do. And here are some really good examples of tools that we're probably familiar with that are classical microkernel type of architectures. So if you actually wanted to build an application on Firefox because it's a plugin type architecture, but not make it a web browser, you will have a really hard time making it look not like a web browser, because at the heart of it, it is a web browser. So when your domain actually changes, you can't really quite anticipate whether it's going to change that same sort of dimension. Now, if you are trying to optimize and you know that you're building something that's a web browser, something like this can actually support that. But the microkernel will always sort of constrain where you can make changes, because you can't actually change the heart of it. And this is actually quite an important thing to think about when we're designing and picking tools, whether or not these tools are actually helping us support the changes that we need to have with our domain, because we may not be able to anticipate where our business is going to go next, and whether or not our architectures can actually support that. So, as I said, let's have a quick look at not just the technical side, but the domain side as well. So we go back to our layered architecture. We go back to our example of thinking about what happens if we actually want to add a Twitter handle to our customer's kind of representation. What parts of the system does it affect? It can potentially affect lots of different components in different areas. Now, we actually have something in advantages as we adopt maybe Java 9 with modules, that will actually help us create a lot more stricter boundaries around parts of the system. But in the current sort of Java ecosystem, we have packages and we kind of have some safety. If we hope that people remember some of the sort of areas of the code base which shouldn't interact with other parts of the code base. But because we can sort of open up our IDs and import classes willy-nilly, that becomes very hard to do at a very practical level. It's very easy to sort of violate boundaries of domain concepts, and we have access to everything, which makes it easy to sort of allow domain concepts to blur across module boundaries. And so in this kind of architecture where we don't really have explicit divides between different components, pre-modules, then we might actually need to make quite a lot of changes across the entire system. And so this kind of architecture really doesn't support our kind of domains shift. Now, microservices are kind of an interesting one, and one of the reasons, if you're actually doing microservices well, is hopefully you've applied the sort of idea of domain-driven architecture. You've got highly cohesive services that actually are kind of independent from each other, and they interact with each other through very explicit interfaces. So you've done a lot around trying to understand those interface designs. And each microservice, if it's done well, should have its own encapsulated technology stack. Now, in smaller organizations, it might all be the same stack altogether, but actually in larger organizations, it might actually change. Now, one of the reasons that this actually works in terms of thinking about change is that if we actually want to change the implementation of some layer within a particular service, we can actually do that without affecting other types of services. So if we actually wanted to change the way that we actually store our customers, instead of being a relational database into a graph database of some sort, we can actually swap out that technical implementation without necessarily affecting and migrating all the other types of databases as well. So we can actually shift the technology stack. And if we actually want to change the customer registration process, hopefully we can actually change the sort of registration process that deals with customers at that level without actually having to touch the other parts of the system as well. So our argument when you actually do microservices done really well, and you can do them very poorly as well, is that these things can actually support both a technical and a business domain shift. And actually this is a really good model about why we're actually seeing more companies adopt microservices overall. Because you can actually move really fastly and respond to changes in the market around what the business would like to do. And we can actually incrementally make changes to our technology stack that help us solve problems with the right tool set incrementally, rather than sort of waiting to do everything at once and being frustrated actually that the tools are now sort of updated. So these are just some simple examples around simple architectures that we're maybe familiar with, and maybe viewing it from a lens of, are these architectures actually helping us support technical and domain changes? And there's a whole bunch of architectures like reactive type things and event-based systems that I haven't really covered, but it's interesting for you to sort of think about, will it actually help you support both your technical and your domain changes according to the pace of what the market's actually going? So we go back to our definition of what evolutionary architecture is. And your question is, okay, this is all really great. How do we actually go about building something like this? And this is where I want to kind of talk about different types of principles. And these are hopefully things that you can adopt that will help you guide whether or not you're actually building systems for change. So we should look at these kind of things from both our technical and domain perspective. Now, if we're building evolutionary architectures well, then your technical implementation shouldn't dictate the schedule of how changes actually get made. And we'll talk about maybe some practices about how that actually works as well. Now, if we're actually thinking about sort of how we actually build our systems, they should also support fast feedback. So we talked about incremental guided change. And if we're actually going to sort of test our systems, we actually want to make sure that our systems are fit for purpose, and therefore we need some fast mechanism for that. So we need to actually think about whether our architectures are actually helping us support fast change as well. We need the appropriate level of coupling. Now, we can't really say we want no coupling, because in order for us to do something, we actually have to couple things together so things work. But what we're really trying to do is understand what's the right level of coupling that we have for our system, and have we coupled things too much to each other? And this is a really key aspect when you're actually evaluating tools. So I'll talk a little bit about tool selection later, and maybe about the implicit coupling that we don't think about when we're adopting things, and how it affects our ability to change a little bit later. And a really key aspect to sort of evolutionary architecture is this idea of iterative. So really making sure that we test out our ideas, that we're not going to get it right the first time, and that we find ways of actually changing those decisions and testing our system for change as well. Now, from the domain perspective, if we're doing evolutionary architectures right, then we should have matching business capabilities. And what this means is that we really should be understanding about, based on what the language that the business uses, we should understand what parts of the system we might actually need to change. And we should be actually trying to align technology to business capabilities to respond rapidly to those changes in the market as well. Now, that's really hard if your IT system maps nothing at all to the way that your business operates, because you're always constantly going to have to be working out, well, which parts of your IT organizational development teams need to respond in order to support a particular business user. Whereas a lot of the industry that we're seeing is actually a lot more about the IT team more aligned to around particular business verticals so they can respond to that market need a lot faster. Now, part of this is actually a real good test of whether or not your architecture supports experimentation. And so this idea of evolution is that we can't really predict whether or not we make the right decisions, but we should be able to test for the right decisions if we can get things out. So if we can actually get things out quickly, and we know that it's the wrong thing, or we find out it's the wrong thing, then experimentation allows us to hopefully back that out really quickly, and then go and test something else as well. Now, around the way that we run our business as well, and this is quite different for a lot of enterprise architects I work with, you also end up with a bit more of a decentralized governance model. And decentralized governance is kind of hard because a lot of enterprise architects like to sort of dictate what it is that will be implemented by the entire organization. But if we actually take anything from evolution, is we can't really predict the result of a whole bunch of system effects coming into play. We have to understand what emerges and try to amplify the things that we care about and to try to dampen the side effects that we dislike. And the key part of this is actually identifying what is your fitness function. And the fitness function for us is a really key concept about understanding whether or not your system is evolving to the right things that you care about. And so this is actually a kind of a key concept about understanding, well, what is the things that you actually need to architect for up front versus the things that you don't? And in a lot of sort of architectures that we sort of go to, they're kind of artifacts of assumptions about what the fitness function are. But as a developer, when you come along to add lines of code to that system, you have no real idea about what it is that you're actually optimizing for. And so when you're actually going through this process of identifying your fitness function for the system that you're building, it's really thinking about what are those characteristics that are really important and key for that particular application versus the ones that aren't. And this is where we bring back the idea of your sort of system quality attributes or your non-functionals and cross-functionals, and really try to make sure that everyone on the team, as they make changes, as they make decisions, understands what are those elements that are actually important and unimportant for the things that you care about for ability to evolve over time. And this will be really different, right? So if you're actually trying to design and architect a mobile application of some sort, that'll be quite different from a real-time event-based type of system. If you're trying to build something that will require huge amounts of privacy, so things like a voting application, you'll have different characteristics that you'll want. You know that you might need to scale to the UK population if you're building something for the election coming up. And so they're things that you won't be able to, you know that you'll actually need to design and architect for. But what's really key around this is actually not just simply saying we need to do these things and they're the things that we optimize for. It's actually thinking about what do you do to measure success around these things. And I think this is an exciting time of where we are in the industry because we've moved along quite well of actually being able to measure a lot more of these types of attributes. And so our challenge for a lot of you is really thinking about when you're actually thinking about your fitness function, what are the metrics that you can have to know whether or not you're successful around these things? And what tools can you have to actually make these things part of your test about whether or not your system is fit for purpose in your environment? So a really good example is when you're actually thinking about high-performance applications. What we're seeing a lot more with companies that can actually evolve their systems is actually a lot more automated performance tests in their sort of production CD pipeline. And what that means is, as people are making choices, they can actually run choices against a known quantity about what is successful or not. The same thing can be said with a lot of security tools, is that there's a lot of things that you can actually test for and make sure that you're being compliant, rather than assuming that you have manual processes for this as well. So a key part to actually understanding evolutionary architectures is actually starting to identify what it is that you're trying to optimize for in your environment of change, because there'll be things that you don't want to actually optimize for, and there'll always be trade-offs around some of this stuff. Now, it's kind of key because these are the things that are known knowns. So as responsible software developers, we should be able to talk to people and non-technical people about these system quality attributes, about the impact it has on development or infrastructure costs. And these are the easy parts. But there's a whole bunch of unknowns as well. And they're the things that we actually have to optimize for as well, which makes it a challenge. And one of the key things that will actually help you do this is actually thinking about how many generations can your system actually support? So when we think about evolution from a biological sense, you kind of have two sort of animals of some sort or organisms, and they actually have to sort of procreate in order to spawn a new generation. And so one of the interesting things about looking at sort of the animal world is actually looking at those generations that can evolve and adapt a lot faster, is because they have this idea of shorter lifespans and this faster procreation period because they can pass their genes on to the next kind of sort of generation, and they might be a lot more successful. And if you actually think about this from a software sense, what is it that would be the equivalent for us as generations? What is it that lets us test whether or not the changes that we made, code functions, new tools, libraries, something that we've added to the code base, and let us test whether or not it's actually fit in production? So is the time frame for this really long or really short? And a lot of this comes down to your speed of getting code from a sort of development workstation into production in use. And this concept isn't really new, but it's really key of actually thinking about how long this is and how long, if you can actually reduce this time to actually improve the number of generations you can actually have. So this idea of generations is really this idea of cycle time. And this is stuff that you'd probably hear about if you're sort of living in the continuous delivery sort of space. And what you really want to do, if you're thinking about this, is optimize for short cycle time. Because what this means is you can actually test more of your changes in production a lot faster, and you get more generations out in your sort of software, and you know whether or not the changes you make are the right ones. But what's really key about this is a lot of people focus on how fast does it take for us to get code out into production. And they forget about some of the prerequisites with continuous delivery. And that's really key about this idea about repeatably and reliably as well. And so a lot of organizations forget about, we can actually ship code really quickly, but can we actually do this in a confident manner that give us our ability to test whether or not changes are actually successful? And so the whole bunch of practices that help us support these are actually things that we should be adopting if we care about agile architectures as well. And two books that are really highly recommended around this are obviously the Continuous Delivery book, but also the Phoenix Project, which is kind of talking about not just the development side, but also the operations side and the process of how we get software out into production. So there's a lot of different sort of aspects to this. I've talked about some of the principles. We talked about some of the key elements of what you can actually do to drive evolutionary architectures. Now, one of the difficulties is where do you actually apply this? So if with any tool or approach, it's kind of important to actually understand you don't apply it to everything. It makes sense to maybe think about change in the context of what you're actually trying to achieve. Now, when we actually think about tools, frameworks, architectures, we often go through this kind of choice of build or buy. We kind of go in our head, should we actually pick a product and build off that thing? Or should we actually just start from scratch and then assemble something from scratch? And it's not really that clear-cut. It's not really one or the other. It's normally kind of a spectrum of stuff. So our architectures are often a mishmash of some products as well as some bespoke code. And it's really trying to think about what are the trade-offs that you get with that. Now, I've worked with a lot of architects as they're going through this process of making choices very early on. And I think one of the hardest things about an architect is you're trying to do the right thing, and you have a lot of pressure. So you're trying to make as many decisions as possible, but you often have the least amount of information in a planning stage, and you might commit too much to things that you don't know if things are actually going to pan out in real life. And so one of the things that a lot of people do when they're going through this process is, well, when I'm actually choosing between products or bespoke code, what do I gain from that? And that leads us to think about looking at things through what do we get from the tools that we actually pick. And so if we look at the types of options, we think about this idea about build versus buy. So if we think about custom code, and we're building a storefront of some sort, there's a lot of things we're going to actually have to build. We're going to have to build, components that help us register customers. We're going to have to build some sort of shopping basket. We're going to have to do some sort of payment type things. We're going to have to manage searches. There's a whole bunch of things that we actually want to build because it's all custom code. And so, that's going to take a long time. And that's certainly a trade-off. At the other end, you might be tempted to fall into a sort of COTS sort of thing, so components off the shelf, or some sort of software product. It's really nice that this vendor offers this whole customizable thing that allows us to make changes around some of the options and configurations around this kind of platform or product. And that's really good because we're viewing it from the perspective of how much business value can we deliver to a client right now. Now, if we actually look at this through the ability to change, that kind of is an interesting thing, right? So if we actually look at custom code, we actually can kind of make changes to that however we like. So we can restructure the code, whatever we like to do. We can make the core product do something that the other product doesn't really make, currently do, and we can do it at our own schedule as well. Whereas actually if we're looking at something like components off the shelf, maybe you're allowed to customize some things, or if you do, it'll cost you significant amounts of money, and you're going to have to wait according to the vendor of how long we can take to actually implement that from some sort of vendor-specific schedule. And so we're making sort of these constant trade-offs around this. And this is really kind of key to think about, which is, what's the type of changes that you actually want to support in the system that you have? Can you predict whether or not your business is going to be really stable and therefore match some sort of predefined product sort of spectrum? Or are you going to be building everything from scratch so you can actually adapt to the market as much as possible? And if I think about some of our sort of emerging startups here in the UK in particular, it's kind of interesting, right? Because there aren't really any predefined products around new industries. And so what we're actually seeing a lot more with these sorts of clients is they're building a lot of the software because you just can't simply buy it off the shelf, right? There aren't standard components that you can simply put together that allow you to suddenly produce a new sort of market software that satisfies the market demand, because there isn't anyone that does that yet. But maybe if you're a more of an incumbent type of system and you're just trying to maybe create another online presence, maybe it makes sense to use a component off the shelf. And this is where actually we're thinking about maybe where does evolutionary architecture fit into this. So when we're actually thinking about the sort of software that we build, there's sort of value that software brings. So commodity software are things that we don't generate us a lot of value, right? It's like stuff we have to have. So a really good example is maybe the operating system on your laptop. So we need it to start up other applications, but it's not really a value-generating thing. It's the sort of basis for how we actually do things. And software in businesses is kind of similar as well. There are some systems that you just kind of need. So Office software might be a really good example of everyone needs a word processor, some sort of Excel kind of type thing. And you don't really need to make a lot of changes to these sorts of things. So you get security updates as they get delivered, but it's not a key essential part to adopting change at the same pace as the business. At the same time, there are some things that you kind of do need to make some changes to. So perhaps your email system has a certain workflow that you want to enforce, and there's certain rules that you want to enforce around how people manage meetings or rooms. And so you do need to make some changes for that sort of stuff. But once again, they're not really value-adding kind of software. They're kind of supporting software that helps the business, but it's not things that you actually need to make a lot of changes to. At the same time, there's a whole bunch of software that sometimes we build that would be potentially high value generating, but we may not need to make changes to it. And these are kind of your experimental type of situations. So I see a lot of teams that go down and adopt a lot of sort of the rigorous automated testing practices. They want to automate the infrastructure, do all of that sort of stuff for experimental software. And it's actually probably the wrong time to do this sort of stuff because you don't know whether or not there's going to be demand for that software yet. And so if the business says, actually, we're going to can this innovation sort of project because we don't want to actually go down this path, then you've invested a whole bunch of time automating things for one use case. You don't get the benefits of that sort of automation. And so these are kind of your experimental types of software that you actually don't really care about, how you support change. Now, the key ones are actually these strategic ones. And if you actually think about your sort of systems in your companies that you have, you'll probably have some pieces of software in that ecosystem which are the money makers. And these are the strategic ones. These are the ones that the business always wants to sort of tweak, make a change, and is your sort of differentiator off the shelf. Now, these are the areas where you actually want to start thinking about applying evolutionary architecture to. Now, if you actually had a product off the shelf and it's your strategic system, what that also implies is a competitor can come along, replicate your business model, and have exactly the same strategic system, therefore you don't end up with a strategic advantage. Now, if we're actually trying to match our software capability to that, we actually want to be able to evolve our systems to match that, make changes that make our system really different. Therefore, we want to be able to control all of those decisions as much as possible, and that's where evolutionary architecture makes sense. We want to be able to support changes from both the technical side as well as the product side. So when we actually think about evolutionary architecture, the key thing I want you to think about as you go back is really thinking about how well is it that your decision-making process supports this idea of guided incremental change. Have you got your fitness functions identified with the metrics? And have you got some sort of automation or some way of actually testing for success? Have you actually optimized for things that allow you to defer decisions so you're not too coupled to a particular tool of some sort? We looked at sort of products, COTS, libraries, and frameworks and the trade-offs of that versus, say, custom code. And do you have a way of actually getting fast feedback so you can actually get as many generations of your software out as much as possible? And there's a whole bunch of practices and tools that you can do that with around the sort of continuous delivery sort of space. And if there's anything that you want to go back to and think about to support evolutionary architecture on your particular systems, it's really three elements that you really want to think about. So one is really around this idea of architectural choices. So what are those tools that you're choosing that create too much coupling, that prevent you from supporting both your technical and the domain changes? How much of it is driven by a vendor versus how much of it can you control? And also, is it important for the type of system that you're actually building? Is it a strategic system or is it something else? It's not just the technology that we should actually be looking at as part of this process, though, because how an organization works also affects that. And it's also thinking about sort of a decision-making process and thinking. So if you're actually evolving a system really rapidly, you might have lots of teams in different ways actually working, making decisions that's optimized for their particular problem. You actually have to think about how you govern that. And actually what that means is the sort of enterprise architect role of trying to have standards across the organization comes up with trying to emerge working standards out of the group rather than trying to predict and dictate something from above and assume that's the right thing. So one of the ways that it often changes this role is actually rather than this idea of the enterprise architect knowing what's best for the organization, is actually trying to visit different teams and trying to seed good practices and come up with an idea of what is the right, consistent, best practice for our system right now, but recognize that this will change as our system evolves over time as well. So our decision-making process of how we evaluate tools, of how we allow people to experiment to make sure that we can actually test for these things and know whether or not it's a good thing for a new change in the ecosystem is really key to allow us to make changes to our system as well. And the third element is really thinking about the organizational and cultural elements to this. And so this is thinking about, well, how do new systems get architected? How do you evolve an existing system and adopt some of these practices? For a lot of people who have sort of large legacy systems and they're thinking about going down this path, it's quite a long way to actually be able to evolve a system that wasn't really designed to do that. So is there ways that you actually can grow a new system on the side of your sort of legacy system and adopt some of these practices? And this is kind of the approach that Martin Fowler's written up called strangler architecture applications, right? So you're slowly strangling this old legacy as you evolve a new system off to the side. So that's the three elements that I'd like you to sort of think about when you think about evolutionary architecture. I'd like you to thank you for listening to this talk and invite you if you have any questions or comments. Yes.
So, hello? Is it working? Sounds like
Yep, I can hear you.
So we have quite a big piece of software that's quite resistant to change. And I think one of the things that we've found that's the trickiest bits is when we've got a lot of dependencies and things.
Yep.
Or whether, even if it's one dependency that's quite tied in,
Yep.
if that stops being supported or whatever,
Yep.
then that can be a problem as well. So I guess, yeah, do you have any thoughts on managing dependencies and that kind of thing, or is that a bit of a separate topic? Or
Yeah, so no, so dependencies are actually a key heart to this idea of trying to minimize the amount of dependencies, and it comes down to really coupling. So the fact that you have a lot of dependencies is the idea that there's a lot of different types of coupling. I have a longer version of this talk that talks about maybe implementation patterns around this sort of stuff, but if you're familiar with the hexagonal architecture or the ports and adapters pattern that Alistair Coburn talks about, that's actually a really good example of how you sort of isolate dependencies into a single part of the system. So a really good example might be if you depend on a particular, say, SMS provider and you're interacting through a SOAP API of some sort. Rather than everyone in the system call the SOAP API, you end up having one part of the system that is kind of your representation of that, the adapter to that, it's isolated, that dependency, and then everyone else uses that single sort of part of that dependency. And what that means is that change, the domain change, so at some point maybe that SMS provider becomes unreliable, doesn't scale to what your business needs. Your business decides, actually, we want to change that contract, we want to move with a different provider. Let's change that. Oh no, now it's like a REST API. Where do we go in our system to actually make a change? Because we've isolated the dependency into a single part, it's very highly cohesive. Everyone else is dependent on our custom code for that. Actually, we can support that change really rapidly because there's only one part of the code base that represents that. So if you're building something new, really thinking about particularly external dependencies and pushing them out to the sides of your system. That's the idea with the ports and adapters and this idea of hexagonal architecture. That can really help with this idea of supporting change and is a really good complementary pattern for that. If you have a system where you have a lot of dependencies in between, there's no easy way around that. You have to start working out how you break up those dependencies. And it's the same sort of thing when we actually see people move away from, say, monoliths to microservices. You know, part of it is actually starting to understand what are those dependencies, and that's the key element of it. I'm really hopeful that with things like Java 9 and the idea of Jigsaw and module stuff is that it helps us understand those modular dependencies a lot more explicitly without having to have separate processes that maybe help us think about those at a higher level a lot easier. But yeah, it's not an easy thing if you have a lot of dependencies. But if you do, isolating them is a really good way of actually dealing with them, and then trying to break them up is the other sort of aspect. Good question.
What sort of advice would you give to someone who's trying to endeavour to do evolutionary architecture in a brownfield environment where you've got SAP on one side, Salesforce on the other, some legacy black boxes, but you've got a change in IT direction and you kind of want to start delivering at a faster pace? Because that's the reality that I kind of see more, quite often. What gems have you got for for that kind of space?
Yeah, it's quite hard when you're kind of like, I guess, an integration vendor to a certain degree of trying to put products together. And our advice for a lot of customers is that if they're deciding to buy products, so that means that they're not really strategic systems. They're kind of things that maybe that they want to get quick, rapid testing of. We recommend customers actually don't go down the path of trying to customize those components as much as possible. It's often better to align your business processes to whatever the product does, rather than trying to customize that product. Because A, you'll be locked to a particular vendor, but also you'll be constrained by the types of business changes that you want, not at the same pace of what your business probably really wants. It'll be whatever your vendor will allow you to do. So as much as you can, it's really about adapting business sort of processes that maybe work with a workflow or whatever system that you've chosen to go down. But the other side is really trying to think about how much that you can decouple, and this comes back to the dependency thing, your sort of unique sort of contributions to the ecosystem of software. So rather than building things in a sort of proprietary way that gets plugged in or installed into a particular product, how can you build off the side and then do lightweight integration? And so what that means is, once again, you're isolating the dependency of some product to an external dependency. Theoretically, if you wanted to change that, you should only have a small part, but you still keep the essence of maybe what's unique and custom to your particular application. So it's really hard because it depends on what business you're actually trying to run. But the two bits of advice are really try not to customize, don't go down the path of trying to customize products that weren't really meant to be designed for this, because it leads to a whole world of pain that make it difficult to test, to quickly cycle, get sort of fast feedback around that in a confident, reliable manner. They're not really optimized for CD typically. And the other thing is, if you're actually building more bespoke stuff, see how much stuff you can do outside of those products as a sort of integrated application on the side through lighter weight integration mechanisms rather than through some proprietary tool or ecosystem of tools. Okay, if there's no more questions, thank you very much for coming and enjoy your Friday.